Hello and welcome back to another video. And in our previous video we learned the 7 recipes of understanding our data, and actually helped us a lot in peeking our data, getting a good insights and so on. In our previous video we also learned that there are techniques in statistics that we can use to better understand our data. So we could find the median, we could find the mode of our data, the most occurring value, or we can even find the middle value of our data. We can use so many techniques, and we learned that pandas can make things very easy for us, as it provides us with the built-in functions and libraries that actually supports all of these statistic functions, that it actually gives us the answer of all of these things, like the mean, median, and mode, and it could even give us the complete descriptive statistics about our data. So it's time for us to, before we can, we will be doing pre-processing as we move along with more videos, but there's one concept that we should be very familiar with before we can do any type of pre-processing, because there's no use of pre-processing if you don't know how to apply EDA, or exploratory data analysis, on our data. Now, exploratory data analysis in simple words is understanding your data using different means of using the means like visualization, or summarizing the data with the visualization. So it's like you have a record of millions of data, like you have 1 million records in the data. So how do you just go ahead and get a good insight of the data? So a very irrelevant technique would be to actually go ahead and look at all the numbers. So you cannot just go ahead and look at all the million numbers to actually get some good insight of the data. So a good way to do this would be to actually visualize the data, which actually gives us like a very brief intuition of what our data is and how it's behaving. So if you wanted to like find out whether the age column in our data is positively skewed or negatively skewed, or is it correlated with or with some other attribute in our data. So this could be done very easily if we actually visualize it, right? So exploratory data analysis could be subdivided into 2 parts. The first one is the univariate analysis, where you simply go ahead and do the analysis on a single variable. So you want to actually go ahead and try to visualize the age, and if you wanted to visualize the age, you can just simply go ahead and use the techniques involved in the univariate analysis, where you simply plot the univariate visualization diagrams to understand what the single variable is doing. And on the other hand, if you wanted to actually find out the dependencies between variables, so you wanted to find out whether this variable is being affected by another variable or with another attribute. So a very highly increasing age might be increasing because of the highly increasing birth rate of some gender. Like there are a lot of boys being born in a particular year, so the age is increasing very quickly. Obviously this does not make any sense, but you can think of this in a very practical way, that how one variable might affect another variable. That's what we do in the multivariate analysis. So before we move on to the multivariate analysis, I'm actually going to go ahead and give you a very good overview of what the univariate analysis does. Alright, so what we are doing here is we have used the pandas library, and I'm also using the scikit-learn data sets here, which I'm actually importing a toy data set which is called the load iris. And if you have worked with data before, you must know what this data is. This is the flower data. Like we have a flower type, iris flower, and what this data set contains is it contains the information about the 3 different types of flowers in the iris flower. And I actually kind of use the diagram here as well for explaining what this data set is going to do. So right now what I'm going to do, I'm just going to go ahead and import the 3 libraries, pandas, scikit-learn, and matplotlib, and then I'm also loading the data into my data variable. So if I just do this, you can see that I've loaded this, and then what I'm doing is I'm just going to go ahead and I'm using the data and the columns to fill, and the feature names, and I'm just combining everything together in one data frame. And now if I just go ahead and print the data frame out, let's say if I just go ahead and print this out, you see that I have a perfect data frame here, which is showing me the sepal width, which is right here. You can see that this is the sepal width. This is called the sepal width of the flower, and this is called the sepal length. And at the same time, you can see at the same point, you can see that there's a petal width as well. So we have also petals in the flower, and then we have different classes. So you can see that you kind of get the idea of this data, that we have sepal width, sepal length, petal width, petal length of class 0. The class 0 might be something like versicolor, or it might be setosa, it might be virginia. So these are like the types of iris flowers that are out there. So based on this data, it can be classified as the setosa flower. So based on this data, it can be classified as the virginia flower. So you get the idea. So this is the kind of data we are using, right? And now what we need to do is we need to actually get a very good idea about this. Well, what we wanted to find out is if I wanted to plot the histogram, or let's say I wanted to do the univariate analysis on any of these columns, I would use the histogram, or I would use the density plot, or I would use even the box and whiskers to find out the outliers in the data. Now we will be doing this one by one. So the first thing we are going to do is we're just going to go ahead and plot this using the histogram. So how do we do this using the histogram? First of all, the data frame that I have created, what I'm going to do is I'm just going to go ahead and say plot. The plot function simply plots, it uses the matplotlib library to plot the data. It could be anything. So if you wanted to do the scatter, you could just simply go ahead and just tell the kind, and then what kind of plot do you want. Right now I want the histogram, so the short for histogram is going to be hist in pandas. And then what I can do is if I just go ahead and plot this out right away, so you can see that it just goes ahead and plots every single thing in one diagram, but we want it to be separate. So just for the sake of explaining, I'm just going to go ahead and do this in a separate diagram, right? So I'm going to say layout equals 4x4. I want every diagram to be 4x4, and then what I need is I need the subplots of every single histogram. So I'm going to say subplots equal true, right? And if I just go ahead and do this, you see now we will have a subplot, and this is actually very small. I think I should make it a little big. So I'm going to go ahead and say fixed size. So fixed size equals I'm going to make this 20 by 20, so it's easier. It's easier to see what's happening. So if I do this now, you'll see that we instantly get a histogram of each and every single attribute. So how do we understand this histogram? Now the histogram is simply the values. Histogram is simply a plotting of the values over an interval, or of it could be defined as the frequency of our data. So how is our data increasing and decreasing? And then there are these, you can see that actually gives us the bins. So these are called the bins. Now what are the bins in histogram? First of all, the bins are like, you can see that right now this is one bin, which is showing that it lies between it lies somewhere between 3 and 3.5, and then you also have another bin, and we can see that the bins are basically showing the distribution of our data. So how is our data distributed? So our data might be lying at some range of interval here, and then it's actually increasing at this range, and it might be it's at the very top at this range. So it's like the lower version of the density plot, which we are going to be covering in our next which we are going to cover in the next part here. So you can see that the histogram kind of gives you a good overview, a good visualization of how your data is divided into different frequencies, and how it's distributed over the interval, or over this continuous range of data, or the continuous range of the x values, right? So I'm just going to go ahead and do the same thing for, I'm going to draw the density plot now, and you will see the difference. Why do we need a density plot over a histogram, and why is it really important to actually use the density? So if I just go ahead and plot the density plot right now, so okay, so we are having some error. It's because we just want the density plot here. So I'm just going to comment this out, and I'm just going to go ahead and print the density plot, so that you can already see. And actually this is not a good way to do this. I will just go ahead and say so what I need is I'm just going to remove the layout here, because the layout is making it 4x4, so we cannot see the distribution properly. So I'm just going to remove the layout, and now you will see that we have a clearer version of what the density plot might look like. So the density plot is just an improved version of histogram. Our histogram was was using the bins to distribute our data in different intervals, or in different buckets of bins. But it was not smoothing the data. It was not giving us the very perfect curve. It was kind of giving us the curve because you could see the bins going up and down, so you kind of get the idea that it's going to be similar of how it will look like in the density plot as well. But again, that is not the very efficient way. So I'm actually going to do one thing. I'm going to actually copy the histogram, and I'm going to draw a histogram with this. Okay, so I'm going to do this hist, and then in the final I'm going to say PLT.show. If I do this, you see what happens. Alright, so I think I should first of all show this one, PLT.show. Whoa. So if I just print this out, so what you see is going to be a histogram. Obviously I'm just printing out the histogram. Oh my god, I'm just gonna go ahead and print the histogram right here. And what you see is you can obviously see some curves right here. You see that it's kind of similar to how our density plot was looking like, but what our density plot did was it smoothed the data out. So in density plot, if you're using the kernel Gaussian smoothing or Gaussian kernel smoothing, if I'm pronouncing the pronunciation right, what the kernel smoothing is doing, it's using a mathematical formula to put these the histogram values or these range of values. You can see that these are range of values. So all these values are basically the x and y values, and then we have the range of those values. We're putting this into the formula, and it gives us a smoother value, a value in fraction or in points. When we plot those values in the density plot, it becomes a very smooth curve, and that kind of gives us a much more better understanding of our data. So this is exactly what we're doing in the density plot. Right, so I'm going to do this. Alright, so I'm going to go back to the density plot, and alright, so if I just go ahead and plot the density right now, so you see that this is exactly what we're getting in the density plot, right? So we're getting a smoother version of our data, and by looking at this data, you can kind of get the idea that that these data right here are basically negatively correlated because they're more towards the negative side. So this is 0, and our data is going more towards the negative side, and it's negatively skewed, so it's skewed towards negative. And you can see the classes right here, since they were not going towards any side, and they're perfectly symmetrical, so each and every one of those mode, median, and mode are actually same. So if any of the mean, median, and mode are different, so if we have different medians, different modes, and different means in our data, we might see the skewness in our data. So what is skewness? It's the variance of mean, median, and mode. So if you have different means, if you have different mode, and if you have different medians, you will see some skewness on our data. And at the same time, if you have no skewness, you'll see that it gives us this perfect symmetrical density of our data, or simply perfect distribution of the data. So you kind of get the idea that we're using the density plot to get a good idea of how the mean, median, and mode is working, and how many. So you can see that this is the multimodal data because it has multiple modes in our data, and there are multiple occurrences. So in our classes, we had the 1 class, we had the 0th class, and we also had the 2 class. This is exactly what's showing the occurrence of 0 class, the occurrence of 1, and the occurrence of 3 class. These are the most occurring values, and that's why I have these 3 modes in my data, or you can call this the multimodal. So the next thing we need to understand is the box plot. Now, what is box plot? Alright, so what is box plot? The box plot is so we in the previous video we learned we could actually use the describe function. So where is the describe function? So yeah, we used this describe function to print out the descriptive statistics of our data. So let's say we wanted to count our data, we wanted the mean of our data, we wanted to calculate the standard deviation of our data. We wanted to calculate the minimum value of the 25th percentile, 50th percentile, or even there's one more thing that I haven't written down here, was the outliers of our data. So what we can do is we can use the box plot in Matplotlib library to visualize every single thing, all of that stuff in just one figure. So I'm going to do this. All right. So what I'm going to do is I'm just going to do the same thing. I'm just going to copy this, and instead of density, what I'm going to write here is I'm going to write the box here, okay? And that's it. So if I do this, you see it instantly gives us the box plot, right? And what you see from the box plot here is that if you see these circles right here, these are called the outliers, and the line at the middle right here, it's called the 50th percentile, or it's called the middle value of our data, and this is the maximum, and this right here is the minimum. So it's giving us the range of our data. So this is the maximum data, and this is the minimum data, and that is at 50th percentile, the 75th percentile, and 25th percentile, and that's the 0th, and then we have the 100, right? So you kind of get the idea. The box plot simply goes ahead and gives us the complete information of how our data looks like. And at the same time, if you take a look at this, you see that the data which is equally distributed will not have any outliers. As we are seeing in the class, we only had 0, 1, and 2 as our numbers in the data. So you can say that there is no outlier in this data, and you kind of get the idea that this is the minimum and this is the maximum. And then again, we don't have any outliers or anything that is falling outside of the mean, median, and mode. So we have a perfect distribution right here. So you kind of get the idea that we can use the box plot to get even a more visualized version of our descriptive statistics, right? So for now, I'm just going to keep this till univariate analysis. In our next video, we will be learning the multivariate analysis, how we can use the multivariate analysis to understand the correlation between our attributes, and how we can understand that one attribute might be affecting another attribute, and what attribute to keep and what attribute to be removed, and what attribute should be removed, so that it's not important in our data, so we don't have to keep it, right? So that's it for this video. Thanks a lot for watching. Don't forget to like, subscribe, and if you have any queries, don't forget to write down those queries in the comments. I will make sure to reply to you. Adios.